Solve the following system of equations using the process of elimination. So our first equation here is minus 6x minus 4y equals 16. And our second equation here is 4x minus 2y equals 8. And again, we're using elimination. So looking at this given system here, we don't see any of the variables with opposing signs that have the same coefficients that cancel immediately. But one thing that I am noticing is equation 1 here can be simplified. So we'll make that the first thing we do. We always want to check that anytime you're given a system, see if you can simplify any of the equations. And so we're going to start here by, we're going to simplify equation 1. So let's see, we have, again, equation 1 is minus 6x minus 4y is equal to 16. And then thinking about the left-hand side here, we know that both negative 6 and minus 4 have a negative 2 in common. Negative 6 can be rewritten as minus 2 times 3, and negative 4 can be rewritten as negative 2 multiplied by 2. So we're going to start here. Let's factor out the common factor of negative 2. So simplifying this, I'm going to factor negative 2 out of the left-hand side, which leaves us with 3x plus 2y, and that's equal to 16. So then to simplify, we are going to divide both sides of the equation here by negative 2. So we have negative 2 divided by negative 2 goes to 1. And then we can even make a little note here that minus 2 is going to go into 16, negative 8 times. So this simplifies to 3x plus 2y is equal to negative 8. So this is our new equation 2 here. Well, it's not, we should be more careful. It's not new, it's our simplified equation 2. Or simplified equation 1, pardon me. So what we've shown is that this given system, our given system here, minus 6x minus 4y equals 16, and equation 2, which we haven't touched. We could simplify that as well, but we'll see momentarily why we have not. So this given system is equivalent to our simplified system, where equation 1, we can rewrite this now as 3x plus 2y is equal to negative 8. And equation 2, again, remains the same. That's 4x minus 2y is equal to 8. So we are going to actually use this simplified system here to solve. And then hopefully you're saying to, or you're observing that with this form we have a plus 2y in equation 1 and a minus 2y in equation 2. So now these two equations have the same coefficient with opposing signs, which will make the process of elimination a little bit easier. So now the first thing that we want to do is we're going to eliminate y here. So we are going to add equation 1 to equation 2. And the reasoning behind this is to eliminate the y variable. So if we eliminate y, so adding equation 1 to equation 2, and then solve for x. And I want you to note this is only one possible way to solve this. If you didn't solve it exactly the same way as me, that's okay. As long as your algebra is accurate and consistent, you're fine. So I'm taking equation 1. I have 3x plus 2y equals negative 8. And I'm adding equation 2 here, which is 4x minus 2y is equal to positive 8. And so we see positive 2y minus 2y goes to 0. 3x plus 4x is 7x. And then negative 8 minus 8 is 0. Or negative 8 plus 8 is 0. And then to solve for x, I am now going to divide both sides of the equation by 7. 7 divided by 7 gives us 1, and we are left with x is 0. So this is the x-coordinate of our solution point. And then step 2 here is to substitute what we just solved for. We're going to substitute x equals 0 into either equation to find the corresponding y. So we substitute x equals 0 into either equation to find y. So I'm going to use equation 2. Again, equation 1 works fine as well. So let's recall that equation 2 is 4x minus 2y is 8. And so we want to replace this x here with the x we just found. So we're going to substitute x equals 0 into equation 2. So I have 4 times 0 minus 2y equals 8. And anything times 0 is 0. That disappears, leaving us with a minus 2y is 8. And then last but not least, if we divide both sides here by negative 2, negative 2 divided by negative 2 is 1. And we have y is negative 4. Okay, and so our final answer here is the coordinate point xy. So when x is 0, y is negative 4. And so what is this telling us? This tells us that the two equations in the system, or we can even say the two lines in the system of equations intersect at the point 0, negative 4, which we just found. So those two lines in the given system of equation 1 and equation 2, are going to intersect at this ordered pair.